Hello, happy 2018. It is me, Dan, streaming live on a Friday, as I hope to and expect to all of 2018. I'm sure I'll miss some Fridays here and there, but this is the Coding Train. I'm starting a new year fresh. But I hope that some of you were able to tune into my end of year live stream where I broke out a keyboard and tried to sing some songs. Hopefully none of you actually watched that. It was really awful. I'm just hoping that everything seems to be working. Yeah, so here's the thing. I really had planned to do some grooming and freshen up. But I don't know if you know this. I kept this background page here because it's really, really cold. Of course, some of you probably live in parts of the world where it is much colder, and it is even colder than this year-round. But for New York City, it's quite cold, and I find that this is like having a built-in ski mask, basically. So as soon as the weather warms up a little bit, I will get back to the being a little less, I don't know, wilderness man thing that look that I'm going for right now. Okay, so yes. I see that there are some viewers from Quebec, which, as we say here, Quebec, which I think is the Americanized pronunciation of Quebec, right? Am I right? I don't know if I'm right. But maybe to your chagrin or maybe to your happiness, today is the day where I'm making a commitment to continue doing a set of tutorials and examples and coding challenges around AI and machine learning, and so in the broadest sense. What I'll be starting with here today is continuing my playlist where I was building a little JavaScript neural network library from scratch, bit by bit. That's what I'm going to do probably for the entire time today, up until about 4 p.m. Eastern time. I'm kidding. The audio is out of sync. You know, this is what happens. I cannot control this, the audio being out of sync. Although actually, hold on a second. Let me see. Usually I say that I can't, but oh my goodness. Hold on. Let me look here in my settings here. Because I do something. I do actually have a built-in delay, I think, that I put in at one point when it was out of sync. I don't see it anymore. No. Delay. I forget where that is in Open Broadcast Studio. Advanced, output, audio, no. Audio is fine. So I'm gonna just keep going. One thing is that eventually these videos, most of what I do today will be edited into shorter chunks that get uploaded later. And the wonderful Mathieu, who helps me with this, can often realign the audio in what I like to call post-production. I don't know what happens. The French is like, something about French is filtering into my head today. Post-production. So even if the audio is a little bit out of sync in this YouTube version, but I think mostly I don't have control over this because I just have a computer. I have some software called Open Broadcast Studio. I have a microphone, some cameras. I send it out to the internet and it arrives on your screens in some form. I'm gonna keep going. Yeah, I know, the beard. What can I do? It's very cold, this helps. So, let me give you some updates. What's gonna happen this month is I will be here every Friday, and I'm gonna continue. I just already said all this. Maybe I'll just get started. Okay, well, this is some other business. It's a new year. Let me tell you about what is out there on the internet that you could look at related to the Coding Train. So you can, if you like the work that I do, you can support me on Patreon, patreon.com/codingtrain. You may also find actually all these links at thecodingtrain.com. You can see here, latest video. This should be me. This should show up here, me live streaming, but I don't know why that's my latest video. You can subscribe, you can like all the videos. I'm told that the machine learning algorithm that YouTube employs to recommend its videos appreciates when you like and subscribe. And you can find some links to the videos here. I don't know what I'm talking about. You can also, anytime I use a book, all the books that I use as learning materials for myself, you can find those at amazon.com/shop, the coding train. You can also get yourself your very own coding train branded. It's not at all. I wish I should have a coding train branded toy. What have I turned into? 2018 apparently is the year of me just trying to sell you stuff. But train whistle here. And that's pretty much it. So that's what you're watching now. I also like to remind you that I use in almost all of my tutorials open source software from the Processing Foundation. I also, full disclosure, am one of the organizers, directors, members, I don't know what the right term is, of the Processing Foundation. It's a project that I spend a lot of time working on, and you can also support the Processing Foundation. It is Processing Foundation is a non-for-profit entity, so your donation is tax deductible depending on the laws of wherever you live, but certainly for the US, it is tax deductible. So those are the kind of, as this is a new year, 2018, things that I would make it. And Simon is making a point in the chat, which is a good one, that I should say machine learning and deep learning instead of AI and ML. So so I think a long time ago when I started this playlist, I kind of had some introductory video that talked about the terminology of machine learning, deep learning, artificial intelligence. I like to think, I agree that there is something very specific that I'm doing right now, which is using neural network-based systems for machine learning. And then that might turn into deep learning as these neural network-based systems get more complex and sophisticated and the amount of data that's going in them gets much larger. But I like to, in this very abstract way, the camera went off already, think about what I'm doing as broader than that. While the tutorials, yes, right now are really zoned in and highly specific, what I'm interested in is, as a creative coder, just to use that term for a moment, what are ways that my systems that I develop can have the illusion of, or perhaps even actually have, intelligence? And in that sense, artificial intelligence is a nice, really broad term for that. So what does it mean for a Boyd flocking with other Boyds on the screen to suddenly have a brain and make decisions based on a neural network? Or what does it mean to have all this data that's coming from some type of quantified self system and visualize it and analyze it in a machine learning-like way? So there's a lot of, I don't know, that didn't really make much sense, but I really want to think of this sort of like broad, that broad picture, and this is not a channel and this is not a tutorial for kind of, specifically related to only data science and, machine learning in a kind of scientific, which is actually a really good thing to learn. I don't know why I said it like this. This is me being scientific, apparently. But so I'm trying to take this sort of broad creative approach. Okay. And yes, Simon keeps pointing out all these excellent things in the chat. You're wondering what this chat that I'm looking at. This is this is a Slack channel for patrons of the Coding Train. There's also a YouTube chat where everyone's telling me that the audio is out of sync. I'm aware of it. Where is that in open broadcast? I just want to make sure I didn't. Yeah, I'm going to just take a minute to look at this audio issue one more time. Where? Open Broadcasting Studio, audio delay. Where is that setting? Audio out of sync. Sound settings. Advanced tab, audio global. I don't have an advanced tab. File, clean collection, tools. Oh, under settings probably. Oh, advanced. I do have an advanced tab. Audio default. I do not see a delay. Stream delay, 20 seconds. 20 seconds? Now all these people will tell me, for some people it's okay, some people it's out of sync, which means there's probably nothing I can do about it. At one point though, I did add a setting clap. All right, everybody. Let's start off 2010 with a nice, I'm going to do two things actually. One thing I want to know is if my audio is different than my sound effect audio. This is just out of my own curiosity. Okay. Little live stream debugging. So I am now going to clap. And so my questions for you are, did you hear the clap before you saw the clap? After you saw the clap? How long was that delay? Now, I really want to check this also. I'm going to do this TikTok sound. No, that's not a good one. I'm going to do the buzzer sound, and I'm going to raise my hand when you hear I'm going to go like this when the buzzer goes off and see if the buzzer and my finger are at the same time even. No? I don't know. I don't know what I'm doing. Oh, there's a delay in that sound. It doesn't start at the beginning when I hit the button. Never mind, that was a bad test. I'm going to hit the snare drum, and now. Is that? So 200 milliseconds. Sound was, right. See, that 200 millisecond delay, I think I have a 200 millisecond delay. Audio ahead. So where is that? Settings, advanced. Somebody watching must know. Somebody must know Open Broadcast Studio. Audio. Maybe it's actually in, hold on. Maybe it's actually in here. Mic. Advanced audio properties. I found it. Volume, sync. Oh yeah, there is a sync offset by 100 milliseconds. Interesting. Yeah, I know where it is now. So I wonder if I should, I'm going to delete that. I'm going to get rid of the sync offset. I got it. Can get rid of that offset. Okay, I got rid of the offset. And I'm going to see, is it worse or better? I know everybody says, who cares? I don't want to waste, don't worry, I won't waste too much time on this. But I can fix it. Worse. Same, worse, better, same, worse, same, worse, same, worse, same, worse. Oh, this is very scientific of me. Okay, I think I know what to do. And I've got it now. Everyone, be amazed at my amazing ability to fix the audio sync issue. And here we go. Ready? Here comes another clap. It's going to be perfect. All right. So I made it 300, everybody. That's what you people in Patreon, in the Slack channel are telling me. You can also use, I really should use this bell, but you can't. It's hard for you to see it. So I think I got it perfect. Great. Okay. So let me talk about some things. Number one, I want to mention this book. Again, you can go to amazon.com/shop/codingtrain. This is a book that I used. First of all, let me back up a little bit. Let me open up the playlist. YouTube, Schiffman, and what's the one that I'm looking for under playlists? This one.
Hello, welcome to...
Okay, so this is a playlist that I began back in, when did I do this? I think it was, when were these videos published? It doesn't tell me here. These videos were made at the end of May, I believe. and some maybe perhaps in June. And then I had this bicycle accident, and I kind of took a couple months off. And then when I came back, it was the beginning of the semester, and I was teaching other stuff, so I wasn't really able to get back to this. So this now will be my primary topic for this semester, which doesn't mean, when I say primary, I'm still planning on doing I have some GitHub stuff that I want to keep doing. I got to go see more of those coding challenges that I want to get out of the way. I really want to do some more videos about working with processing in Eclipse and Java to make processing libraries. So I do have a bunch of things on my mind that I would like to get to. I need to get to iTerm at some point. I know. I did Chrome extensions though. But at least for the next couple months, this is what I'm going to be focusing on. Now, this was actually fortuitous. What's that thing? The silver lining of looking on the bright side of having had this delay is new stuff has happened. Number one, if I go to my Twitter, I just tweeted about this because this is just so darn good. Way better than anything I could possibly make. 3 Blue 1 Brown is a YouTube channel. And 3 Blue 1 Brown has several different videos about neural networks and how they work. And they're really good. So these have come out since I started that. And so these are a really excellent resource for a deeper dive into the mathematics. These are animated, they're edited, there's a lot of beautiful work done, thoughtfully done on these videos. They make so much sense, they have wonderful animations. It's very different than my style of like haphazard trying to explain things in live coding. But so I think that's good in that there's no way I'd ever be able to make something of this quality. I don't have that within me. But this is an excellent resource to dive a little bit deeper into some of the maths behind how neural networks work, as along with or before you watch my videos where I'm going to try to code this stuff. So that's number one. That's excellent. The other thing that's happened is that a new JavaScript library has come out called DeepLearn.js. DeepLearn.js is a JavaScript library that is, you might call it like a TensorFlow for the web. It's like, it doesn't really help if you don't know what TensorFlow is, but it is a hardware-accelerated machine intelligence library for the web. So what I'm doing right now, what I will continue doing today, is create this. Oh, and let me open up Atom. Create this. Here we are. This is good. I've been working on this somewhat ridiculous matrix. And I'm going to change it to ES6 class, but matrix library, which has like a bunch of functions. Like I could add a number to every element of a matrix, or I could add two matrices element-wise together. So I've been working on this rather absurdly, and I intend to continue and finish this because what I want to have, hopefully by the end of this month, is a complete set of tutorials for building your own vanilla basic neural network in JavaScript with no other dependencies. P5 might be a dependency in terms of how I might visualize and draw it, but the library itself that does the neural network math will all be there. But this isn't really going to get us very far when we want to do some maybe more real world or faster, more optimized projects for the web. And that's where DeepLearn.js comes in. I think I mentioned in some of my videos where I started this matrix math stuff that there's math.js and like GPU.rocks. There's a bunch of JavaScript implementations, but DeepLearn.js, it's a project developed by Google, the big picture research group up in Cambridge, sort of part of the Google Brain initiative. It's an open source library. It's not an official Google product, but it's an open source library. And I encourage you to check out the examples, tutorials, all this stuff. So in relation to this, along with a whole bunch of other folks here at ITP, students and other staff and faculty and researchers, there is a library under development called, if I go to github.com/itpnyu/p5ml, I think, it's not going to be that's not the final name of it in any case. Let me find the repo. P5, sorry, -deeplearn.js. So this is also, why am I not logged in here? I'll sign into GitHub at some point. So this is also a library that's under development that will also allow me and you to do a lot more with these machine learning algorithms. So the plan is, if I can summarize it, step one, build a vanilla, meaning basic with no dependencies, not worrying about being optimized or having it really be very good, but build all the pieces of a neural network from scratch in JavaScript to understand how it works. Step two, replace the engine that does the math, the matrix math that's in that implementation with deeplearn.js so that it works a little bit faster. Step three, start to actually use deeplearn.js, which has a set of classes and objects for different neural network architectures to do projects. And so let me just show you, for example, if I go under examples, and let's go under this KNN image classifier. Let's actually run this for fun. Let's see if this works. This is, by the way, a simple, if you've seen Google's the Creative Labs project Teachable Machines, which I'm also going to reference in some tutorials and use as an explanatory. This is very similar to that. And so, I got to turn my webcam on. So here I am. I'm going to do this. So that's me training this neural network system, this machine learning system, let me just say that, category A. Now I'm going to do category B. And now what I want to do is start guessing. So in theory, it should know whenever I go, I'm A, and whenever I go, I'm B. And I'm going to start guessing. And here we go. Hold on. Training on my this design could use a little work, but usually it'd have a higher resolution. But you can see it here. Let's look at confidence of A is. Oh, I'm standing in front of it. Hold on, move this over a little bit. So you can see confidence in A and confidence in B. So these are the kinds of creative projects that we can think about making. Also, and there's lots more. So I want to get to all this, but I've got to start somewhere. Okay, so that's my plan. And we can see where I left off. This is where I left off. Well, I left off update on machine learning video series, which was kind of like, I'm going to take a break from this for a while. But I left off here, matrix math part 2. So what I hope to get done today, although I'm quickly running out of time as I just randomly talk, is matrix math part 3, which will be doing actual matrix multiplication, matrix product, and then implementing the feed forward algorithm for the neural network. And then next week, I hope to come back and look at training and backpropagation. So that's kind of my plan. Okay, so I'm looking, and it looks like I see Chris, who has done a lot of work, ITP student who's done a lot of work with the P5ML library, looks like is in the live channel. So hi, Chris. He'll answer all your questions. Okay, now, so before I get started, let's just see if there's any questions I can answer in the YouTube chat really quickly. Hi, from Sweden. It's All right, there don't look like there's too many questions there. People are asking for shout outs. I don't know. What is the Amazon store for Coding Train, please? Okay, I'll answer that question. Yeah, I should mention also Siraj. I didn't mention Siraj. This is another YouTube channel which I would highly recommend. Now I feel, that was kind of like assumed for me. So I also would highly recommend, if you're interested in this topic, this channel is amazing and completely dedicated to this topic. So I would definitely check out Siraj's channel, which I watch all those videos as well. Okay, yes, I will be making some processing things in the future. Will you make a tutorial on how backpropagation works on convolutional recurrent nets? I don't know. Again, my plan is to do all the pieces of the vanilla neural network from scratch, But using a library like DeepLearn.js, that's going to have the architecture for a convolutional neural network built into it. So I can really just use the library to implement a convolutional neural network. But I certainly will talk about what it is and how it works. But I don't intend to build every new neural network architecture that's been developed that comes out in a paper from scratch in JavaScript in this. I don't think I'm capable of that, and I don't think that would make sense. So, okay. The store. So there are two places if you're interested in Coding Train merchandise. There's codingtrain.storenvy.com. And then there is where I have all the books that I'm using, and there's a bunch that I need to add. Amazon.com/shop/thecodingtrain. Okay? All right, so now I think I can get started.
This is a 3. It's sloppily written and rendered extremely
It's 3 Blue Brown. One is talking to me.
but your brain has no trouble recognizing it as a 3.
So these videos are so good. I can't, it's like, I watched it and I'm like, oh my goodness, what am I doing? I'm like a complete crazy person. This is the model of educational stuff on the internet. But, I don't know, I guess different styles, different strokes for different folks. Hopefully what I'm doing also has value, but those are really good videos. All right. Okay, so this is going to be a little tricky because I got to get sort of back into this frame of mind. I did try to do that. I did some reading and I actually rewatched some of my videos, which I almost never do, just to try to see what I covered, and that was kind of a shock to see what they're like. But this is where I am in. So let me get this. I don't need the whole desktop open here in Atom. I wonder if this is a new year, if I should just switch over to using Microsoft Visual Studio. I guess not today. I'm not ready for that today. I feel like it's a new year. I should start I want to use Glitch. I love Glitch this year. I want to use that. I'm going to just close all this stuff. I'm going to close this. Let me go to Terminal. Desktop. Now, open this up. One thing I just want to check here also is I might as well go ahead and update to the more recent versions of P5. And then what else was I saying I want to do? I need to run a server. And, okay. So there shouldn't be anything there, really. This is what matters. And, okay. All right. Yes, I'm going to do the convert to ES6. Okay, so first I'm going to make a video that the first video that I'm going to do here, I guess, will be 10.8, which will be kind of like a little bit of an interstitial video of moving over to ES6. And Santa Dan, I know. One thing I asked this in the Slack channel, but I didn't get a firm answer. Let me try to look this up. If I were to use the array function map, the array function map is not, can I look for it somewhere here? That's actually, it's not actually ES6. Yeah, it's ES5, I guess. I just think of it as ES6 because I'd never used it. And then when I was looking at ES6 stuff, I was looking at the ES6. Okay, so I'll mention that as well. Because I want to convert everything to ES6, keep finishing the tutorial, and then I also want to use some advanced array functions but I'm going to not use the arrow syntax and all that stuff. But I'm not going to do that at first. Okay. Okay, so. It is 2:36 p.m. We have about an hour and a half left. You can hear me blowing my nose probably because I forgot to hit mute, but life will go on. Yes, it's true. I am back, and I am in some very cold weather, revisiting my machine learning playlist, which is really not at this point a machine learning. I had something stuck in my beard. Let me try that again. Hello, I'm back. I'm finally getting to that neural network playlist, which left off in May, and I'm continuing it. Now, you might be watching, again, you might be watching in the future when it's all been completed, but as you can see, some time passed. And here I am again. Now, the last video in this playlist looked at vector math, and I believe I looked at adding, I can actually look it up here. The last thing I did was this function multiply, which was simply multiplying a matrix by a scalar. So taking each element of a matrix and multiplying it by a single number. Now, you also might notice here, matrix.prototype.multiply. What is that? Well, since I last did these videos, I have started adopting ES6 classes. Class is a template for creating an object that's part of ECMA scripts version 6. Yada, yada, yada. I have a whole playlist about that stuff. If you don't know about classes, you can go and look at those tutorials. But before I move on and finish the matrix math that we need to build this neural network, I want to rewrite all of what I have so far with ES6. So that's all I'm going to do in this video. Okay, so let's actually do that. First, let's wander over. I was first building a neural network object. The idea of a neural network is having input nodes, a hidden layer, and output nodes. So let me first change this to be a class. Class neural network. And then once I have a class, this constructor function actually can now become constructor, called constructor. And you know what the method that I'm kind of adopting is when I pass arguments in, I actually give those arguments parameters, I guess in this case, in the constructor definition, I give those parameters the same name as the properties attached to the object, and they are differentiated by, say it with me, this dot. That's right. This dot, this dot, this dot, this dot. Okay, so there we go. So now I've converted the neural network class, it wasn't a class before, but the constructor function into an ES6 class. Now I've got to do the same thing with the matrix constructor function. So this was the matrix constructor function, and I now want this to be a class called matrix, and I'm going to put this around everything. And I don't know what Adam wants me to do, but okay. And then this constructor function is now called constructor. This is what happens in the constructor, and this is just the randomize function. All these functions that are attached to the prototype can just be written by their name inside of the class. This is add, and this is multiply, and that's what we're going to be working on in the next video. All right, so in a moment I want to check. Let me check to make sure this is still working. So if I go to the browser, refresh the page, I should be able to say things like let M equal a new matrix, 3 by 3. I should be able to say console.table M, and I can see, oops, nope, I made this mistake in my previous videos, console.table M.matrix. And you can see there it is. So this seems to be, and I could say M.add the number 5, and then I could look at it. So it still seems to be working. I have a matrix that's 3 by 3. It by default it's filled with zeros. If I add 5 to it, it looks like 5. If I say m.randomize, now I can look at it again. It has random numbers, so it's still working. That's good. Now here's the other aspect of this. One thing you might notice is that I'm doing a lot of loops and array operations. Like I'm saying, hey, for every element of this array at index I, at index j, do this thing, etc. There are actually, you probably know this already, I'm very slow on the draw here. Whoops. Sorry, this was not on. You probably know this already. I'm a bit slow to catch up with these things. There are a bunch of useful array functions. I often think of them as ES6, like this video is about converting it to ES6, but really they've been around before ES6. And these are these functions called like map, reduce is one, fill is one, and filter. I actually don't remember what filter does. I know what these do. And I think having access to using some of these array functions will make this matrix will be useful in the development of this matrix library. However, for simplicity's sake, as I go on into the next video, I am still going to do all of the matrix math operations in the sort of long-windedest way. That's not actually a word, but in a very long-winded way. Then at the end, I'll try to come back and use some of these. And I should mention that where am I going with this? Eventually, I want to learn and understand all of these matrix operations and write the code for them to kind of get my hands in there and figure it out. But in the end, I'm going to actually take out all of this stuff and replace all of the matrix operations with a library from Google called deeplearn.js. So stay tuned. There's going to be a lot more about this library and a helper library where deeplearn can use with P5 in future videos. All right, so I think that's pretty much it for this video. I'm now ready to kind of like get back up to speed, and the things that I need to do are finish this matrix class with more useful matrix math operations. I need to be able to multiply two matrices together and understand what it means to do that. And then also, finish this to add the rest of the functionality for the neural network that stores all the pieces of the neural network in these matrices and implements the algorithm. So I'll be getting to all that stuff. So see you in the next video. Oh, audio way before in the sync was not fixed for the other one. Okay, that's fine. You know, unfortunately, Mathieu will have to fix that. But I can fix that right now for the future. Whoops. It didn't occur to me that would be an issue. So hold on, let me fix that really quick. I didn't realize there's two separate audio settings for each. No, it's the same. That's weird. The audio settings are the same for both. So hold on, let's just be sure about this. Whoops. And of course the camera's going off. Whoops. Cancel. Oh, weird. Yeah. Weirdly, the video, that's so weird. I can actually see the delay I could probably restart Open Broadcast Studio. But, do you guys mind if that's really weird. Wonder why it does that. Is there an advanced video? Is it possible I have a delay on this? Hold on, sorry, just excuse me for a second. Yeah, no. So I don't understand. I don't understand why it's doing that. Yeah, unfortunately, I know I could probably have separate settings for each one, but I think I'll spend all my time doing that. Yeah, Simon's mentioning let in the for loop. Where did I? Oh my goodness. Oh, thank you. All right, let's see. Wait, this video is not over yet. I forgot that I should also replace var with let. Replace all. All right, why? Why do you keep needing me to put my password in? Hold on a second. I think something weird is going on. I just realized something a little bit weird is going on. I have a feeling. Yeah. I know why it's asking for my password every time I change it because these files are not owned by this particular login. And so I have to fix that. Okay, that should be fine. All right. Whatever. All right. Yes, I do read this chat, Jeffrey, but just very rarely. I don't know what to do about the other. Yeah, I can see that it's. I can actually, yeah, wow, that's a huge delay. So I didn't realize this. I can actually see the delay in I can actually see the delay in in my preview window. But why would it be different for different cameras? Does anybody know how to do the video delay in Open Broadcasting Studio? Settings, advanced, video, output, streaming, The camera was on restart stream. All right. Let me restart the stream. YouTube's actually usually pretty good at it. If I shut it down and restart it, it keeps it as one thing. Why not? I'm just curious. Why not try? I'm going to just try that, okay? Everybody, I'll be right back. Yeah, the delay actually looks completely gone to me now, which interestingly enough, there might be a delay there because I have the built-in delay. So check this again. And here. Did that fix it? Okay, great. All right, great. Okay. All fixed. Thank you, everybody. All right, so I just have to remember. So let me think about this. What do I want to do? I want to multiply. Okay, so first of all, I got to get my terminology right. Let's see. So maybe you guys can help me with this. One thing that I want to do is actually let's go back to this particular video. And let me see what the whiteboard looked like at the end. So this is, oh, I'm in the wrong camera. Okay. You can now see the difference in the beard. So this is what, can I please move out of the way? My goodness. Here. That's a little bit better. There we go. All right, so this is what I had before. If you don't mind bearing with me for a second, I'm over here. I know you can't see me, but I am erasing the array functions from the whiteboard. And I am going to kind of rewrite some of that stuff. Well, that video looks so dark. So scalar element-wise dot product. So I'm just going to write these. Scalar element-wise, and then 3 dot product. Okay, so I just made that list, which you can now see there. And yeah. So what I want to do is get my terms right. What I'm talking about is matrix multiplication, but there are there are three possibilities. And let me just think about this, and I'm going to kind of like do this twice. I know people don't really like it when I do that. Actually, no one's actually ever said that. I'm going to try to get rid of that glare. Okay. So, in other words, when I'm doing multiplication, there's I could multiply by a scalar, in which case that has to be element-wise. Or I could multiply by another matrix, and then that could be element-wise only if this matrix is so if I have a matrix, some arbitrary matrix U, same exact size as U, right? If I'm going to do, if I'm going to do element-wise, this is me just practicing, by the way. I'm going to do, it has to be the same exact size, right? Because if I have two matrices and I want to multiply each element by each other element, it's got to be the same size. Or it could be, like, weirdly the same number of rows only. No, but then or I could multiply by a vector. I could multiply also by a vector, just do kind of like element-wise per row. But that's, but this is called, this element-wise same exact size, that's called that like how do you say that? That product that's, I'm going to get this wrong. Hadamard product, right? So that's the Hadamard product, I believe. This is, and don't worry, I'm going to go through and explain all of this again in a second. Hadamard product, Hadamard. And then if I'm doing if I'm taking one matrix multiplied by another matrix and doing the dot product, I could also do, then there's the dot product, which with two vectors would give me a scalar. And in this case, the row, let's look at this matrix. Let's find like a Wikipedia reference. Matrix dot product. Whoa, look at this nice. Forget about Wikipedia. Thank you for this. Okay, I want to look at this. The matrix dot product, we end up with a matrix that has the same number of rows as the first. The order matters. That sort of distributive or associative property. I've got to learn what all these things are. I don't remember. Associative property. Come on, just give me an image to show it to me. Right, this is distributive associative property multiplication. Right, yes. Which is that the order, I could change. This is not true for commutative. Yes, K. Weekman, we are still at commutative property. Is that what I'm looking for? Thank you. Yeah. Either order, but not true for matrices, for matrix multiplication. Okay. Oh, there's cross product. I don't want to get into that. So what I'm trying to do is it correct to call this the dot product? And that is you have to have, the order matters, A dot B. B has to have the same number of columns as A has rows. Columns must match rows because, and let me just practice this again, if I have A, B, C, D, E, F times G, H, A, B, C, D, E, F, G, H, I, J, right? If this is what I'm doing, this equals, I haven't done this in so long. I'm going to do this again. Don't worry. And I'm way off the screen here. This equals, I'm going to get a 2 by 2, right? Because I'm going to get 2 rows from here. I always get, wait a second. Yeah. Yeah, I always get the number of rows, and then the number of columns comes from here. No. Because I can multiply this by, oh, I'm confused. I confused myself. Matrix product. Columns has to equal rows. Rows doesn't have to equal columns. Thank you. I knew that was right. I knew I was backwards here. Okay. Yes. The columns of A has to equal the rows of B. This was not going to work. D, E, A, B, C, D, E, F, A, B. Oh, where did C go? A, B, C, D, E, F. Right? So, for example, what am I doing here? This is 2 columns. Well, this would still, oh my God, I've lost my mind. The number of columns, oh yeah, this is fine. The number of columns has to equal the number of rows, because what I'm going to get now is, this is, you always say rows first, so this is 3 by 2, and this is 2 by 2. And so my result, and actually the one we care about the most here is just, because what we're going to, but let me explain it this way, is we're going to get 2 by 2 here at the end. And the way that we do that is with the dot product. So it is, let's pull up that Math is Fun page. Right here, where we basically take the dot product of the vectors, right? So we take, right? This example is probably a better one. Did I do it wrong again? Did I do it wrong again? Let's just do the same as the, so the columns has to equal the rows. Wait a second. Hold on. Oh, yeah. No, I'm right. I just like I like this. So you can see here the columns has to equal the number of rows. This is actually kind of a nicer way of looking at an example, because neither of the matrices is a square. So I kind of like that. So I wonder if maybe that's a better, we can borrow. We can borrow A, B, C. That's what, we can start the way I had started, D, E, F. And then we could say, for example, A, B, C, D, E, F, A, B, C, D, E, F, G, H, I, J, K, L. Okay? So I don't know why I wrote the L that way. This totally makes sense. Of course, the number of columns has to equal the number of rows, because we're going to take these three. There we go. We're doing the dot product. The reason why I was saying the number of rows has to equal the number of columns, I was thinking about it backwards. I knew that way I had to take the dot product of this times this. I was thinking of this as a row and this is a column. But this is a row made up of 3 columns. And the length of this is what matters. So we basically make a new matrix by taking the dot product of this vector with this. That goes here. this vector with this, that goes here. This vector with this, that goes here. And this vector with this, and that goes here. Okay? So this would be A times G plus B times I plus C times K. And this would be D times G plus D times I plus D. Okay, I think I've got it right. And what I'm being told, breaking news, is that you can just call this the matrix product. So this element-wise is the Hadamard product, and this is the matrix product. So what would be, P, oh yeah, that's interesting. Okay, so this would be, am I correct about the Hadamard product that they have to be equal? Is there a special way to do it if they're not equal? I don't know that I don't think I actually need this product. So I actually just only need to reference it. Let's see if I have a matrix product. Do we have a nice Wikipedia page? There we go. Is there a nice diagram? Look at this awful diagram. Well, actually, it's probably a beautiful diagram. Okay. Oh, I like this one. Okay, great. Great. Okay, so I can use matrix product as the standard. Sure product. That's interesting. Okay. All right, so now what I need to do is do this tutorial. Oh, I forgot. I have to actually implement the code for that. That's going to be interesting. I'm going to do a terrible job of that, I'm almost certain. You know what's interesting, actually, is I'm going to do a video later this month about unit tests, working with a continuous integration company, et cetera. And actually, one thing that I could do is test to make sure as you modify the code, the math still works. That could be something I could do. Okay, so let me erase all this. I'm gonna redo all this. I had to work it out in my head. Try to make this a little bit cleaner. Okay. All right. Yes, no, I realize that the Hadamard product is certainly useful. I just don't know, and if I were making a fully implemented matrix library that I really wanted people to use, I would want to make sure every math possibility is accounted for. But in this case, I'm just kind of like putting stuff in when I need it for this neural network, so. Okay. Anything else? Oh. I'm looking at the chat. Okay. Everybody's got great suggestions. Yeah. I am not erasing the whiteboard with my hand. I had a paper towel kind of like cupped inside my hand. Okay. Right, people are telling me begin with the neural network, the linear algebra will follow. I got you. What you might not realize is that's actually what I've already done. I have this playlist, and I have introduced all of these concepts, and now I needed the matrix math, so I'm doing it. But that actual, this is happening in a very long-winded way. You know, I probably could in some other universe do all of this stuff in one video that just takes like an hour or something, but I'm kind of breaking this up into parts because I take a long time to do stuff. Okay. Here we go. Now, I don't want to use I don't want to use a square matrix as an example, even though I make it simple, because you can really mislead yourself when you have square matrices and thinking things work in a certain way when they don't. Okay. Oh, what happened here to my... All right. And we are here. this is the video in this playlist, which really comes right after 10.7, Matrix Math Part 2. This is Matrix Math Part 3, where I am finally going to look at... Oh, I can't hear it. Matrix multiplication, or really I should say, matrix multiplication. Okay, so if you recall, what I'm doing, I know I look quite different, but I already covered that. The previous one was made a while ago. Anyway, if I have a matrix, right, and what I mean by a matrix is a grid of values. And let's say I have one that looks like this. A, B, C, D, E, F. This is a 3, no. It is a 2 by 3 matrix. We always refer to the number of rows before the number of columns. Now, what does it mean? And previously with, when I made some videos just about vectors, I talked about this thing called the dot product. But I'm going to change that here and write the matrix product. So first of all, what does it mean to multiply a matrix by something? I could just multiply this matrix by a single number. And that's what's known as, well, it's not really, that's what's known as scalar, sorry. Scalar. If I multiply this by a single number, then I just say, if this was a whole bunch of 1s, multiply it by 2, I got a whole bunch of 2s. You know, if I multiply by 2, double every value in the matrix. And I think actually now I did that in the previous video. I could also do what's known as element-wise multiplication. And that is also referred to as the Hadamard. I don't know if I'm pronouncing that correctly. And breaking news, somebody in the live chat that's going on right now told me that it also is sometimes called a Shor product. And what that means is, imagine I have another matrix that's exactly the same size as this one. And in fact, I could kind of do that a little small over here, and I could say G, H, I, J, K, L, right? So I could have another matrix that's exactly the same size, and if I multiply these together, I have a new matrix which has A times G, B times H, C times I, D times J. Element-wise, each element of the matrix gets multiplied by its corresponding other element. Now, those are perfectly valid, I'm looking for my eraser, perfectly valid ways of doing multiplication. Oops, I don't need to. But what I'm really interested in is the matrix product. And the reason why I'm interested in the matrix product is because I want to use the matrix product for a neural network. For example, this node in a neural network is going to be the result of the weighted sum of all of the input nodes multiplied by weighted connections. And this one is also going to be the weighted sum of all of the input nodes multiplied by weighted connections, and so on and so forth. And so these weights are stored in a matrix. And the inputs come in a matrix as well. So the inputs we could think of like this. And so what I actually need, hold on, time out for a second, I got confused. So if the columns, the number of columns of the first one, the number of columns of the first thing has to, okay, so the weights go here, they're multiplied by the inputs. Got it. Okay, sorry. So if this is how I'm representing the inputs, then you might discover that I have this matrix of all these weights that I need to multiply those inputs by to get the new values of the outputs of this hidden layer. Now anyway, I kind of talked about that in a previous video, and I'm going to talk about it a lot more in the next video when we look at this in more detail. But the point here is that this idea of a matrix product is something that I'm going to need. So what I want to do, don't worry about the neural network stuff so much right now, I'll come back to that. What I want to focus on is how does the matrix product work? So one thing that's very important to understand is a matrix product, which I'm going to use the dot to signify matrix product. Let's say I have a matrix A, this is my matrix A, and I'm going to have another matrix called B, and that matrix is going to be equal to the following. G, H, I, J, K, L. One thing you might note, one thing that's really important is A, matrix product B, does not equal B, matrix product A. The commutative property does not hold, right? 3 times 4 is equal to 4 times 3. They're both equal to 12. But this is not true here. And another thing to realize that's super important is that if you have, hold on, if you have A dot B, it's only, oh, the camera went off. Ah! When did that happen? How long ago did that happen? Okay, must not have happened that long. Oh, 3:11 p.m. Must not have happened that long ago. Oh, no. Welcome to the Coding Trade podcast. I'm trying to figure out what did I last say? I'm waiting for somebody in the patron group because they're a little bit more trustworthy than the YouTube chat. 1 minute, 36 seconds ago. Yeah, I don't, doesn't matter how the exact amount of time. I want to know what the last thing I said was. Don't worry about the neural network thing. Okay, that's the last thing I said. Okay. Wow, so that was quite a while ago. Now I've lost my rhythm here. Let's see. Got it. Oh, yes. So the whole thing where I was talking about the commutative property. Okay, fine. All right. So I'm going to pretend I finished just erasing the neural network thing. And I know I'm in the wrong camera. Okay. So don't worry about the whole neural network thing. I'm going to come back to that in next video and go through that in detail. What I need to do here is just understand, I know I need the matrix product. How does it work? And then we'll see how it's applied in the neural network example. Okay, so let's say that I have a matrix A and I have another matrix B. And that matrix is equal to G, H, I, J, K, L. I'm writing the L like that so that I can see that it's not a 1 or whatever. Okay? So I have these two matrices. The way that I write the expression A matrix product B, I'm going to write it like this. A dot B. The dot as the indicator for the matrix product. Now, couple things that are really important here. One, the commutative property does not hold. A dot B does not equal B dot A. This is not true. And you're going to see why in a minute. You know, if I were to say 3 times 4, that's equal to 4 times 3. They're both equal to 12. But again, this matrix product is a different kind of multiplication. This commutative property does not hold. So that's kind of key. Another thing that's really important is the matrix product is something you can only do if the sizes of the matrices match up. And what do I mean by that? Now, one thing you might have realized, like if I was doing, when I had that example of the Hadamard product, that's only going to work if I have two matrices with the same exact dimensions, right? Because if I don't have the same exact dimensions, how can I multiply each element by the other element? Because some elements might not exist in one of them. But something even completely different is going to go on here. I need to have, for this to be valid, I need to have the columns, right? The columns of A equal to the rows of B. And you'll notice I made these do that. So I have to have, however many columns I have here, 3, I have to have exactly the same number of rows in B. Otherwise, this won't work. And the reason is, what I'm actually going to do is, the reason why I use this dot here is I'm going to use the vector dot product. Vector dot product. So you might have to go back to one of my previous videos where I talked about the vector dot product. Of course, I'm going to do it here again. But what the vector dot product does is it takes kind of like the sum of all the elements multiplied, the element-wise elements multiplied to each other. What do I mean by that? So if I say A dot B, what I'm going to get is a matrix that has the number of rows of A, I'm confused here, and the number of columns of B, right? So let me time out for a second. Little time out. I'm gonna pause at that explanation, right? Because I want to go back to my example. If this was multiplied by the number of columns, E, F, G, is multiplied by the number of rows, the result I get is actually the number of rows of the first and the number of columns of the second. Yep, okay. I had to work that out in my head. Is this visible? Okay. I'm going to get, when I take one matrix, the A matrix product B, the result is also going to be a matrix. Now, how do I know the dimensions of that matrix? It's going to have the number of rows of A, which is how many? 2, followed by the number of columns of B, 2. So in the end, I'm going to get a 2 by 2 matrix. Now, this is going to be different with all different matrix dimensions. And after you watch this video, you can make up lots of different matrices and play a game with yourself to do this matrix product with pencil and paper. And boy, won't that be fun. I'm going to go do that later myself, I'm sure. But here we can see I'm going to get a square 2 by 2 matrix. Now, what am I doing here? How do I fill in each of these blanks? So I'm going to just put a little blank square here. I know I need 2 by 2. Well, what I do is I take the dot product of the row of the first one with the row of A with the column of B. Right? So it's almost kind of like the intersection. This first element, right? I got to get the first row of A and the first column of B. That's why they have to have the same number of rows in B as columns in A. So what this actually is, this value here is the dot product of these two vectors, which is, actually, let me just come over here, which is A times G plus B times I plus C times I. Okay, so that's this element here. Now, let's do this element here. Well, I'm in row 1. So I stay with row 1 of A, but now I'm in column 2, so I go to column 2 of B. So now this particular value is A times H plus B times J plus C times L. Okay? Ha! That's good. Now let me do this one. This one is the second row times the first column of B. D times G plus E times I plus F times K. And then this one here is going to be the second row times the second column. D times H plus E times J plus F times L. Okay? So that's the math. For any arbitrary set of matrices, you take the dot product of all the rows with the columns to fill out your resulting matrix product, and you must have the same number of columns in A as rows of B. Okay, so pause this video if you want, try to draw some diagrams, Google matrix product, Google image search matrix product, you'll probably come up with a million visual examples of this. Watch 3 Blue, 1 Brown's videos on linear algebra, which will probably teach this in a much more intuitive and nice way, but I'll link to that in this video's description. I'm now going to try to implement this matrix product in code. Okay. What's the chance I got something? No one is yelling at me in the chat, which means I might have actually gotten that right. Did I get that right? Do I deserve a nice sip of some cold water? Oh shoot, people are saying C times K. Oh, I said it correctly. I just wrote the wrong thing, right? Okay. All right. Minor correction. Hopefully I said the right thing, but I do have something wrong here. A times G, B times I, C times K. This should be a K right here. Ta-da! Okay. I said I. Darn. Oh well. I thought maybe I at least said but it's fine. Get a little bit wrong. I'll get lots of nice comments about that. Okay, so now I need to implement the code for this. I think I can do this. Do I need to think about this and try it first? All right, let's do this. Okay, let me just do this. Okay. Okay, so let's now go to our code and try to write an algorithm to do this. Now, once again, my plan, and I'm in multiply. I wonder if I should let me write a new function and call it product. No, let me call it multiply. When I want to multiply a matrix by another matrix, by definition, I want the matrix product in this case. So I'm going to do the same thing I did in the add function, which I'm going to check. If n is an instance of another matrix, do it one way. Otherwise, assume it's a scalar and do it another way. And so it's still doing this every time I save. Hold on. Hold on. Pause for a sec. Yeah. Okay, it's fine now. Hold on. Let me do this again. So if n, I'm going to do what? Sorry. I'm going to do the same thing that I did up here in add, where I'm going to check, is it a matrix or is it a number? So if n is an instance of a matrix, I want to do the matrix, do the matrix product, otherwise do the scalar product. Otherwise, scalar product. So I need to write the code for the matrix product. Now, what do I need to check first? Is this right? Yeah. What do I need to check first? Now, first, I need to make sure that the number of columns of A is equal to the number of rows of B. Otherwise, I can't do a matrix product. So I want to say if n is B, so n's rows. So let's say if this dot, do we have rows in a variable? Yeah. If this dot rows does not equal n dot columns, then return, I don't know, undefined maybe, or null. And maybe we'll add an error, console.log rows of A must match columns of B. So one thing we can do right now, let's just even see, let's see what happens here. Let's make sure that this check, oh, I'm in the wrong screen the whole time. I'm the worst. I'm the worst. That was quite a while ago, too. Okay, good news is, I'll just do this again. Let's do a lot of undoing. Sorry, everybody. That's me electroshock therapizing myself. Okay. A system that would track me is good, but I need to be able to override it because I often want to just reference this and then come right back. Okay. I'm just going to start this whole thing over. I'm going to make one video tutorial today. That's kind of how it is. I do need more than 2 hours to really get a lot done, it seems like, in these video tutorials. Maybe I could just, instead of doing the feed forward part, I could do some other coding challenge or something. Okay, so let me go back here. Okay, so let's try to implement the math for this. So where I'm going to do this is in the multiply function. And I had written that before to do scalar multiplication. And I'm going to do the same thing I did in add, where I'm going to check what is the thing coming in. Is it a matrix, or is it a scalar, or etc. So I'm not going to bother with the Hadamard product. I'll add that into this matrix library if I ever need it. But I'm just going to check, is n an instance of a matrix? If that's so, then I want to do matrix product. Otherwise, I want to do scalar product. Okay? So now I need to write the code for the matrix product right there. But first, I must check, are the columns of A equal to the rows of B? Otherwise, I cannot perform the matrix product at all. So I'm going to come over here and I'm going to say, if, I'm in the right screen, yes, if the A is this matrix object, if this dot rows, no, if this dot columns does not equal n dot rows, I kind of don't like that this is called n here, but whatever. Then, and I'll use this more strict equals here, then I need to return like undefined or something. Like, just get out of here. This is no good. And I'm going to console.log columns of A must match rows of B. Columns. Now, I could be more thoughtful and I could use a try catch and some error handling, but I'm just going to do this for right now. Just to be some. And let's actually make sure this works. So if I go back to loading that code and I said something like A is a matrix that is 3 by 3, and B is a matrix that is 5 by 10. If I say A multiply B, I get undefined, and it says columns of A must match rows of B. So that's working. And I could just say B is a matrix of 3 by 3 also, then they match, and I would say A multiply B. I still get undefined because I haven't done it yet, but I don't get that error message. Okay, so now I need to create a new matrix. So I'm going to say the result is a new matrix that has the number of, what did I say? It has the number of rows of A and the number of columns of B. So it has the number of rows of A and the number of columns of B. Ah, come on. Adam keeps wanting me to put my password in. Okay. All right, so that's good. Now I need to do each spot. So for each row, whoops, for each row and for each column, I need to do the dot product of values in column. Oh my goodness, this is so simple. It's kind of simple when you look at it this way, right? I need the values of, I need the dot product of the vector of the values in all of row J. Time out. I have to think about this. People are telling me, okay. Oh, whoops. First of all, I have an error. Before I can do this, I have an error here. And what I want is, if I'm at 0, 0, I want all of the values, I want to do the sum of all of the values. Whoa. So I want of A, row, okay, so of I. Oh my God. Oh, it's hard. Wait, look at the chat. Console.error makes an error message. That's good. Oh, an OBS plugin to check for movement. Ooh, that's interesting. I need 3 nested loops. I know, I'm just hurt. My brain hurts. It's like really cold and it like froze slightly on the way here. I know I can do this. I know. So let me just think about this for a second. So if I have, let's think about this for a second. If I'm looping through every row as I, so I'm starting here, and every column as J, and you know the convention might be to have these swapped, but whatever. That's what I have right now. I need to take from A, I need to take every element from row I and multiply it by every element of column I in B, column J in B. And then add those together, and then I have ij. Okay, okay. So I need to say, in other words, let's just do this manually. In this case, it would be this dot matrix I times n dot matrix J. Well, sorry, I need another double nested loop in here, right? Because I'm going to take this and add I plus 1, but staying in J plus 1, right? Is this right? I plus 2, J plus 2. I mean, this isn't, I'm making this up because I'm doing this in an arbitrary way. We don't know what the actual rows, this just goes up depending on the number of rows, columns there are. All right, right? So maybe I only need one loop here because I need one loop. So what's that? No, because these could be different. Yeah. K. Weekman is telling me in the chat, another way of thinking about this is I could say, and you know what might be nice, actually? One thing that I could do here, just at least, I think this is going to help me work this out, is I could say let A equal this dot matrix, and let B equal n. Just to have variables called A and B for the two different matrices. And this is still the result. But in other words, what I'm saying is A, and this is B. So A, I, K, B, K, J. So hold on, with K, sum over K. So hold on. So let me put this here. Did I get this wrong? This is B. Is it... Yeah, so you know what's wrong about this? So let's look, now we can get this, right? Here's what I'm doing here. I want to be increasing not the row, but the column. Ah, I did it wrong. I did it backwards. Do you guys like watching these videos where I try to figure it out? I don't know. I could just get it right the first time. I could just like start over and get it right. But what I'm doing is every column of A, which column is, I'm actually using... Yes, it's row I, but I'm iterating over the columns. Of course. So it is this. J. So this is what I need. So what I should be able to say is result, I need another loop for let K equals 0, K is less than, and I could use, remember, I could use A's columns or B's rows. Those have to be the same. So I'm going to use A's columns. Is that right? Yes. K plus plus, and then first I need to say let sum equal 0, and then I'm going to say sum plus equal A, index I, K, plus B, index K, J. This, I think, is right. And then I have to put that in the result. Result I, J equals sum. So if I was using like some other vector library, I could like pull those out and then do the dot product. But let's see here. Let's make sure this is right. I want to, for every element in the results, I want to sum the dot product of all of the column spots in A that's K, with all of the row spots in B. And then I've got the result. And line 57, I'm seeing deep space in the chat says line 57. Oh yes, sorry, this needs to be multiplied. So these get multiplied. I'm summing the product of all of those. Yes. And of course, there are much faster ways. I'm not looking for any efficiency here. I'm just trying to understand the algorithm and make sure I have something that works. Okay, so now I need one more curly bracket, and I think if I zoom back out here, I think I am done. This is the algorithm, right? I have a new matrix that is the size of, and this I should do this down here, the size of A's rows and B's columns. Then I go through it and I do the dot product of a vector of a row of A and a column of B, store that result. Okay, and B, yes, here's another mistake. B equals n dot matrix, right? Because the actual two-dimensional array is stored in a variable called matrix. It's not the object itself has the data inside a variable. Okay, so how are we going to test this? Well, let's look at Did that make a weird sound? I just put my hand on the microphone. Let's create a known scenario. Actually, let's not. I mean, yes. All right. So here's what we're going to do. I'm going to say, I got to remember, let A equals a new matrix, and I'm going to use these dimensions. It's 2 by 3. Oh, A has already been declared. So I'll just keep using var. So new matrix. Let me just refresh the page. Clear. Oops. Sorry. I don't know what I'm doing. Scratch all that. Let A equal a new matrix. That's 2 by 3. Excellent. Let B equal a new matrix. That is what? I'm going to do 3 by 2. That's what I did in my example. 3 by 2. Then I'm going to say A dot randomize. B dot randomize. You know what? I should do all this just in the sketch itself. I don't know why I'm doing this in the console. So I'm going to say, let me do this in the sketch. I actually have a sketch here. So I'm going to, that's a P5 sketch. I'm not going to use anything about P5. I'm going to have A be a new matrix that's 3 by 2. Sorry, 2 by 3. I'm going to say the same for B, which is 3 by 2. Then I'm going to say A dot randomize, B dot randomize, console.log A dot matrix, and console.log, and not .log, .table, B dot matrix. So let's take a look at that. Okay, so now I have two matrices. This is one, and they're with random values in them. Now let's say C equals A multiply B. Console.table C. Ready, everybody? Ready? So people are wanting me to be able to reproduce the results. So let me just do random seed 1. So by the way, random seed is a function in P5 that'll seed the random numbers. So I should, every time I refresh this page, oh, that did not work. Oh, what am I using for random values in my library? Oh, because, right, because I didn't want this to depend on P5, so I seeded it. Whatever, it's fine. I will worry about seeding it later. Okay, now, so I'm going to get different random numbers each time, but we'll see. All right, let's see. So now I'm going to say, let C equal A dot multiply B. Oh, I didn't get anything there. Oh, I didn't console log it. Oh man, console table c.matrix. Oh, I forgot about that part. Okay, here we go again. Shoot. All right. So what's this error? Sketch.js line 11. Cannot. Did I forget to return it? I forgot to return it, didn't I? Okay, you know what might be nice is if at the end of this I said return result. And this actually goes where? Here. Right? I gotta return that result. All right, let's try this again. No. Did I forget to hit save? All right, let's see what's going on. I'm going to stop using that stupid sound effect because apparently I'm doing a terrible job at this. Let's just, are we even here? This is everybody's favorite debugging here. Uh-oh. I'm being told, breaking news. The return is in this for loop. That's not good. Oh, right, because the return was in the for loop. That's terrible. And this says results, and it should say results. Okay, I'm feeling a little bit more confident now. What? Okay. Return result. Hold on. Sketch.11. It's console logging something, but nothing is there. Oh, no, but yeah, I know there's an issue with, hold on. All right, let me debug this for a second here. Oh my goodness. I'm completely losing my mind here. So it's very important to realize that result is the matrix object. The matrix object has this array called matrix, which actually stores the values. And there's no like set function or anything. So what I actually really need to put here is result.matrix, right, equals this. Result.matrix equals, oh no, and then return result, right? So these values that I'm calculating, there probably should be like a set function or something like that. And I probably should have just created the 2D array here and then made a matrix, but whatever. This is what it needs to be. I think we've got it now. Oh boy. Okay, wait. Let me do some console logging in here. Console log result. And then let me say console log result here. All right. So that worked. Ooh, some problem here. Columns and rows are undefined. So something is really going wrong here. New matrix A.rows, B.columns. All right. Let's look at A.rows. Undefined, line 50. Oh, this is the worst. I'm really doing a horrible, so I've done something terrible here. But hopefully, you're watching this video, and maybe this is valuable to you. I have really conflated the idea of the 2D array that stores the values with the object, and I'm using it in all sorts of terrible ways. So let's think about this. This is what I want. A is this, B is N. Now I can get the rows and columns, but down here, I really need to say A.matrix, B.matrix, right? And that goes into the result.matrix. So hopefully this is clear to you, the issue, but let me try to rephrase it again in case it's not. There is this idea of a matrix object. It has three properties: the number of rows, the number of columns, and the actual 2D array. So if I refer to the variable that's the matrix object and I want to actually do something to the data, I have to say the name of the object dot matrix. And I'm forgetting to do that in so many different places. So what I'm going to look at down here is I think now everything is correct. If A and B are the names of the objects, I can pull out the rows and columns from A, and then I can pull out the values from A.matrix and B.matrix, and set the values in result.matrix. Okay. I shouldn't be confident. I really should not be confident. This is a terrible idea, but I'm confident. Okay, so we finally got three things. If this is A and this is B, this is A dot B. Anybody want to fact check for me for this? Somebody in the chat. I'm gonna wait now. This will get edited out. Anybody want to fact check these? Yes, Simon, I saw your comment about the other functions changing the current matrix, not giving a new matrix back. That is true. And I probably should be more thoughtful about that in the library. Put small numbers to be easier to check. Wrong. Doesn't look right. Okay, let's see. All right, I'm going to have to check this myself. 6 times, yeah, it definitely does not look right. It didn't, no, that's right. 6 times 5 is 30. 7 times 1 is 7. 0 times 5 is 0. 37. It's right. It's right. That's good. 7 times 5 is 35. Plus 2 is 37. Plus 30 is 67. So those are right. And then 6 times 3 is 18, plus 7 is 25. That's right. All right, I think it's right. It's right. Yay! Okay, we got it, everybody. Thank you, thank you. These numbers are in fact correct. I took a little break there and checked them. They are right. I encourage you to pause the video and check them yourself to see if you understand how the library is working. One thing that actually could be really useful, I don't ever employ tests ever, really, but I should learn about tests and I should probably do some stuff with tests on this channel. So I think I might come back and try to do some tests that would, if I ever change the code for this matrix library, to ensure that the math still works. So anyway, maybe someday I'll come back and do that. Now, yes, there needs to be a lot of tidying up and refactoring. I can use these array functions, and I'm going to get to all that. But now we're ready. The next video, I can take this matrix library, this matrix class, and use it in my neural network class to perform the feed-forward algorithm of taking all these inputs, multiplying them by weights, and getting new outputs, which then go into other nodes. They become inputs to a hidden layer of nodes, et cetera, et cetera. So I've talked about that in the previous videos, and now I'm going to come back and actually do that. I do want to point out something. Simon in the chat did mention a good point, which is that if you look at all of these functions, randomize affects this actual object. Add affects this actual object. I'm doing something different with matrix multiplication, where instead of affecting this actual object, I'm creating a new object and returning it. So I probably should be more thoughtful and maybe use like a static method for that. And so maybe I'll refactor that sub. Actually, you know what? Let's do that right now. No, I'll refactor that later. Wait, time out. Oh. The reason why I don't want to do that right now, I'm not going to do that right now because I haven't talked about static methods. Oh, no, we're going to do some refactoring. Okay, actually, so I'm going to do in the next video, before I get to the neural network stuff, I'm going to do a little bit of refactoring with this. I'm going to take the multiply function and make it a static method, and I'm going to look at using some advanced array functions like map, reduce, that sort of thing to just sort of clean up the code a little bit. All right, thanks everybody, and see you in the next future videos. Oh, I need transpose. Crud. Oh, well, let's do that. Hold on. Matt's just gonna give me. Let me like re-record the whole end of this video. I'm gonna go back to where I mentioned Simon's comment. Okay. Simon in the chat makes a good point where if you look at this class, all of these functions, randomize, add, multiply, well, up to multiply, they change the object that I'm calling the function on. So if I say matrix A, I say A.randomize, that matrix object actually changes. But with this matrix product, I'm not actually affecting the object. When I say A multiply B, I don't change the value of A. I create a new matrix object and return that value. So I probably should refactor the library to do maybe that matrix product in a slightly different way. And I could use something called a static method. So I'll come back maybe in a later video when I refactor this a little bit, but I wanted to mention that now. But it also reminded me that I'm being told in the chat that later equals never, but sometimes I do come back. I do come back and do the things I say. Sometimes. I also need to transpose a matrix. That is another, whoops. That is another matrix operation that I need. I don't know where to put it, but I need to transpose. You'll see in the feed forward algorithm, I actually don't think that I need this in the feed forward algorithm, but when I get to the training step where I see if the neural network made a good or bad guess and try to adjust everything internally to tune it to get a better guess, I think that I need to transpose a vector. And what does it mean to transpose a vector? To transpose a vector means to just like rotate it. So if I'm correct, transposing this vector would turn it to this. So I might have gotten that wrong, in which case, if you watch the next video, I'll correct it. And if I got that right, in the next video, I will implement it. Okay, so stay tuned. I'm going to transpose. All right. All right. Oh, wow. Orazdow in the chat is saying, I made a matrix library, but it was so much more messy. Is that possible? Could you possibly make it more messy? Okay. All right, so did I get that right about transpose? I'm going to do the transpose video now, too, because I have time. It's not, was I saying vector instead of matrix? All right, fine. What happens when you get older is you start mixing words together. Maybe that doesn't, maybe I'm not, it seems to be happening to me a lot more recently. Okay, let me redo this. All right. Hold on, I have to erase this. Just ignore me for a second. There's one more matrix operation that I need for the neural network stuff. I think I don't actually need it for the feed forward, so I could come back and do it after that. But I do need it for the training aspect when I adjust and tune it based on what the guess is. Well, I get to all that later. The thing that I need is to transpose a matrix. So how do I transpose a matrix? If I have a matrix A with a certain number of rows and columns, the columns become the rows become the columns. So transposing this matrix would turn it into this matrix. Okay? So I'm going to quickly in the next video write a function that does exactly that. All right. All right. All right. All right. Wait. Did I do something wrong again? I see so many people typing. Am I good? Am I good? I'm waiting for somebody in the Patreon group to tell me I'm good. Jose says I'm good. See, I don't. Some people. Yes. Okay. Thank you. All right. All right. You know what I need to do is, because I'm going to want to return a new. All right. Thank you, Simon, for the comment about vectors and transposition. Okay. If anybody can think of a very, very short coding challenge. So Ricardo, there are moderators in the chat, actually, I think. All right, here we go. Okay, another matrix math video. I mean, there's lots more of matrix. There's lots more to matrix math. And again, let me encourage you, I will link to it in this video's description, to check out 3 Blue 1 Brown's YouTube channel, which is a whole series about linear algebra. I'm just kind of implementing the minimum that I need for this neural network example that I want to build in JavaScript. So the missing piece, and I just talked about at the end of the last video, is to transpose a matrix. Transposing a matrix means take all the rows and make them columns. So A, B, C, this row becomes the first column, A, B, C. This row becomes the first column, D, E, F. Now, this is yet another function which requires me, which requires me to make a new matrix. So I'm not actually taking the matrix. I mean, I could take the matrix and redo it, but I think what I'm going to do is let's just write this function, transpose. What I want to do is have a result, I guess I'll call it, and have that be a new matrix that instead of having, right, the rows and the columns become the rows become the columns. So I'm going to say this dot columns, this dot rows. So I'm... This is driving me crazy. That Adam, I think it's because, it's each of the files? Hold on, just ignore me for a second. I gotta fix this. This is driving me way too crazy. I'm gonna rewrite this function. I know what's going on. I copied some code I have different user logins into the computer, and it doesn't think it owns the code. So if I go to like get info on this file, yeah, I did it on the folder. That's so annoying, and it doesn't do it to all the files recursively. So I have to say that this file really belongs to processing, and processing has read and write. And do I really have to do this to all the files? Was there maybe like a checkbox for like doing everything? Does anybody know? I'll just do them individually because I'm... Just bear with me. I just want Adam to stop yelling at me. And now it will stop. Should change the username to coding train. Once I called it processing. Okay. So I'm going to write this transpose function. And the first thing I need to do is make a new matrix, which I will call result again, equals a new matrix. And it has the number of rows that it used to have columns. And it has the number of columns that it used to have rows. And I should be able to just say now, it should be as easy as if I was like ever going through the entire matrix. And I should be just saying that the results matrix ij equals the, and actually I should say the results matrix ji equals this matrix ij. Do we see this? Now, it's possible I got this backwards, but it should be, if I'm iterating over all the rows and columns, every row column position should become the column row position. So I should be able to just say j index I equals of the new matrix is this matrix ij. That should work. So, and then I need to say return again. Return result. Okay, so let's test this out. Could I really have done this quickly? Very unlikely. Oh, why am I saying plus equals? It should not be plus equals. It should just literally be equal. And if I go into the sketch that I had, and all I need is A, so I'm going to have this random one, and then I'm going to say let B equal A dot transpose. And then I'm going to say console.table A and console.table B. All right, let's take a look. I'm not accounting for the number of rows and columns differences. I think that I am. Hold on, let's take a look. Probably get this wrong. Whoops. And of course, I need to console the actual matrix object to see it. Try this again. 674-109-617049, 674-674-109-109. All right, I think we got transpose correct. That's great. So we did this. We're done. We're done with the matrix math videos. And it's the next thing I need to do is actually start thinking about how does this feed forward algorithm work. If I were to write a feed forward function and I were to give it some input, if I were to feed some input, how do I ultimately return some guess? So this is where lots of matrix math needs to happen. So again, if you're interested, I'm also going to link to 3 Blue 1 Brown's video, What is a Neural Network? It's an excellent animated explanation of a lot of the things that I covered in the earlier videos in this playlist. But what I'm going to do is try to write the code for the neural network right here. Once we have that done, I think I'm going to just try doing a couple tests. Like I'm going to solve a problem called XOR, which is a really simple problem. And I'm also going to look at the MNIST data set, which is kind of like the hello world of machine learning with this neural network. And then with the idea of just seeing if it works so that I can then, once I know that it works, I can do some more creative stuff with it. Okay? So thanks everybody, and see you in the next video. Okay. All right, it's after 4, and I think I have to go, unfortunately. But I will be back next Friday, and I will get to the next part next Friday, which will be starting to build this out. And I would say that hopefully it'll go faster, but it probably won't. But we're going to get to all this stuff. Let me just check my messages to see if I got any important message while I see if you guys have any questions. All right, no. Okay, so yeah, I know. I could do, what's a coding challenge I could do before I go? I can't do Tetris. If I could think of something like really simple. Let's look. Let's see if I can make it. What were the ones that I was looking at? Oh no, Rainbow, that I thought were possible. And then I want to see who the ones that I thought were possible I assigned to myself. No. Koch snowflake, true. No. Oh, Langton's ant. No. None of these are very simple. Double pendulum, weirdly. No. Need something simpler. Simple sound pinball. Yeah, I'm gonna reinforce rotating. Oh, there were some things that I feel like I had some corrections from the dragon curve. Yeah, looking at all these suggestions. Langton's ant really isn't that hard, right? And I already have the game of life one. Okay, let's look at that. All right. Squares on a plane are colored variously, either black or white. We arbitrarily identify one square as the ant. The ant can travel in any of 4 cardinal directions at each step it takes. The ant moves according to the rules below. At a white square, turn 90 degrees right. Flip the color of the square, move forward 1 unit. At a black square, turn 90 degrees left, flip the color scheme. All right. All right. All right. All right. We can do this. We can do this. We can do this. All right. We're going to do Langton's ant as the coding challenge for this week. Because when I say I have to leave at 4, I really meant 4:30 because I always know I'm going to take a little longer. But I really do have to leave at 4:30. 4:45, the very, very latest. Let me just send a message here. Just don't mind me. I'm wasting time that I don't have. Ba-da-ba-ba. All right, I'm going to do something here, which is. Okay. I want to find my game of life code. Here it is. And I'm going to copy it to the desktop. And I'm going to call it Langton's ant. And then I'm going to, in terminal, I've actually never programmed this before. Let's open it up. And whoops, what's going on here? Oh my goodness. I have some nonsense code because I was explaining something. Okay, great. So I should be able to use this structure for Langton's ant. So I'm going to allow myself do we all think this is okay? There is so much similar here that is this okay to start my coding challenge with this same make2d array function, these variables that talk about the grid, initializing the grids to 0, and just drawing the grid. A 1 is white. Are we okay with this? Start from scratch. People really think, oh, interesting. Interesting. I will start from scratch if that's what people think. Me, I am somebody who's saying that's sensible. It's just I'm going to end up programming exactly this again. Vote. And people could just, this is like part 2. All right, I'll give it a couple minutes to vote. I'm going to do a poll in both. I'm just curious to be scientific about this. Oh, a lot of people are telling me scratch. Can I at least keep this make2d array function? How about I at least keep that? I think I should at least keep that. People want me to time this as well. All right. Yeah. I'm going to at least use that make2d array function because I don't know. I'm going to allow myself that. And all right, hold on. Whoops. No, look, I'm wasting all this time that I could just be doing this with trying to make a poll in here. Pixels as squares would be fairly neat. Wait, I'm getting some interesting suggestions. So you mean do it as a pixel by pixel level? Make it in processing. That's a good idea. I should just do this in processing. Yeah, let me do this in processing. Because it's so similar, and at least we could see something kind of, that's a great idea. That solves lots of problems. It solves the problem of doing it, whether I should do it from scratch or not. And it also solves the problem of people who keep saying, well, you do more challenges in processing. Yes, and this will be a lot faster to do it on the pixel level. I'll do it on the pixel level. Okay, we're going to do it on the pixel level in processing from scratch. And we'll make a JavaScript version. We'll port the code, don't worry. Oh. Langton's ant. Okay. Okay. All right. Here we go. We were saying open frameworks, yeah. You guys are gonna have to redo it in open frameworks yourself. Someday I'll have a guest do some open frameworks tutorials. I keep meaning to make that happen. Okay. Whoops. All right. What's this thing here? That's the bell. Visible, slightly visible. Okay. So let me close all this stuff. Quit this, quit this, quit this. And we're going to do Langton's ant. Oh, oops. Yeah, replace it. All right. Okay. A grid of checkboxes. That's a great idea. Okay, somebody posted that nice ant image. I don't know that I don't have time to use that, but thank you, because I'm going to do it pixel by pixel anyway. All right, here we go. I'm moderating the chat. Oh, I want this. I think this. Oh yeah, I like this. Okay, here we are, a coding challenge. This coding challenge I'm going to do in processing, and I'm going to attempt to implement this thing called Langton's ant. Now, one thing I might recommend is go back and watch my Game of Life coding challenge, because there's going to be a lot of similarities between these two. This is an example of another cellular automata system. However, I'm going to do this one in processing so we just sort of see a different environment. I will, of course, make a port to JavaScript, so if you make your own variation of this and want to share it on the web, you can look at the P5.js version of this. So what do I need? What I need with this for a cellular automata system, just like, and is it automata? Is it automata? Darn it, I can never get this right. I need to have a two-dimensional array. And this is actually a place where I'm kind of happy that I'm using Java in processing, where I can say I can make this grid a new two-dimensional array. And you know what though? Guess what I'm going to do? I'm going to have every cell be an individual pixel. Because processing is pretty fast, I could do individual pixel settings. So let's, instead of having like a grid of squares that are larger size, I'm going to actually do it on the pixel by pixel level. Let's see how that goes. So let's just decide in advance. Actually, I don't need to decide in advance. I'm going to have a window that's, let's just do like 200 by 400 by 400 to start. And then so the array is going to be a new array of integers, which the same number of spots, width, and height. And it's actually going to just fill that whole thing with zeros. So I don't actually even need in Java. If I was doing this in JavaScript, I've got to like fill it with zeros. But I'm going to just assume that it's filling it with zeros. Great. Now, we should really learn what Langton's ant is. Let's go take a look. So it's a system, a cellular automata system that will produce interesting patterns, and I need to follow these rules. Okay, so squares on a plane are colored variously, either black or white. So we'll say white if the ant hasn't been there. That'll be a zero. Well, I guess 0 is black, white is 1. I don't know. We'll figure that out. We arbitrarily identify one square as the ant. So let's start that. Let's have the ant's location. We're just going to call that, we're going to have that just be x and y. And the ant is going to start at 200, 200. Okay? That's where the ant's going to start. And I probably should say width divided by 2, whatever. So I'm going to say grid x, y equals 1. That's where the ant is. And actually, to be honest with you, maybe I should have that be the value 2. So I can have 0 for, but let's keep going here. So the ant moves according to the rules below. At a white square, it turns 90 degrees right. Okay, so actually, what I want to do is each time, let's make a background of white, I need to figure out what is the state of the current spot where the ant is. Right? So this is the state of the current spot where the ant is. So if the ant, we can look at these rules, if the ant is at a white square, okay, and then we need to keep track of its direction. Which way is it moving? So I also need a direction. And let's do something goofy and do like these. I think that you're supposed to do, like, kind of make constants. Maybe you say final or something, but I'm just going to call them capital. I'm going to say like up. Oh, that's a reserved word in processing. Ant up is 1, 0. Ant down is 1. Ant right is 2. This might be really silly the way that I'm doing this. And left is 3. So I'm going to make up some constants to keep track of the direction. And I need a variable called ant direction. And I can just call that direction. So I already have that. I have the ant's x, y location and its direction. There's probably a nicer way of doing that, but I'm going to keep going with what I have. Its direction, I'm just going to start by going up. That's its direction. So now, if at a white, oh, you know what? I should have those in clockwise order, because then I could just add 1. Adding 1 is turning right, subtracting 1 is turning left. So this should actually be up is 0, right is 1, down is 2, and left is 3. So if the state is white, and I'll have white be 1. No, white should be 0 because they're all starting as 0 because I'm filling it with white. So if the state is 0, then the ant should turn right. If the state is white, if it's 0, the ant should turn right, meaning ant, just direction plus plus. And what I'm actually gonna do is I'm gonna almost in a silly way write a separate function for turning right, because I need to deal with like, So this is direction plus plus, but if direction is greater than ant left, then direction equals ant up, right? So I could use modulus, but I'm just going to be sort of silly about this. You can all do your nice refactoring, and then I'm going to say minus minus, and if it's less than ant up, it's ant left. So this will account for when 0 goes to -1, it should be 3. When 3 goes to 4, it should be 0. And again, I could have done this all in one line of code with modulus, but that's fine. So if state is 0, turn right. And then, what's the next thing? Flip the color of the square and move forward 1 unit. Okay? So then state grid x, y should now be 1, right? That's flipping. And then move forward needs to be a function. So I'm now going to write a function called move forward, which is if direction is up, then y minus minus. Again, I could use a switch statement, a case statement, and all that if direction is right. I could do this with all sorts of fancier ways. Else, if, but I'm just going to really try to, be long-winded about this to understand it. If it's down, y plus plus. Else, if direction is left, then left is x minus minus. Then I need to account for the edges. So if x is greater than width, then x equals 0. If x is else if x is less than 0, then x equals width minus 1. And again, I could use modulus, but I'm just going to be super long-winded about this. And I'm going to do this for y. And I'm going to change that to height. And put y in here. And here we go. Okay, so now I have this crazy long function. Crazy long function for moving forward. It should change the x and y value based on its current direction, and it should wrap around the edges. Okay, so now move forward. Okay, else if what? What could the other, if it's the state is already 1, if there's really only one other possibility, but I'll check. Else if state is 1, turn left. Turn left. Change the state to 0, and then move forward. I think we're done. Let's just run this. It's not going to draw anything, but let's just run this and see if we get any errors. I usually don't like to write so much code without running it first. Okay, it's running, but let's now see. Now all I need to do is visualize this grid. And I should have probably made this. The pixels are in a one-dimensional array, but I'm now going to loop through. And I is every x column, I plus plus. J is every y. I don't want to use x and y because I already used those for the ants. And then, and I could actually, you know what, I really could be so efficient about this. Because I could make, this is very silly. I could make an image. I only have to change 1 pixel each frame. It's really silly for me to, so let's do this. I can't bear, let's do it this way first, but I am going to refactor this because this is really ridiculous what I'm about to do. So the pixel location is I times width plus j. And this is a formula that I have used in countless videos. And I'm going to call this pix for pixel. So the actual pixel location in the window is all the pixel colors are stored in a one-dimensional array. And so I'm going to operate on those pixels. I need to say load pixels. And I also need to say update pixels. So I will refer you to my video tutorials about pixels in processing. There'll be if this is not unfamiliar to you, I'll link to those tutorials. But basically what I need to do now is just say pixels, index pix equals something. Like if I say color random 255, what you're going to see here is, whoops, when I run this sketch, is every pixel is a random color. Now what I want to do is I want to say if grid I j equals 0, then set that pixel to white. Otherwise, if it's equal to 1, but that's the only other possibility, set that pixel to black. And we should see this is just rendering the results of Langton's ant with each and every pixel as a cell in the grid. So let's run this. And we can kind of zoom in and see, is this the correct pattern? Can anyone confirm or deny for me that this is the correct pattern? Let's see if it looks kind of like, so this is what it should look like after 11,000 steps. All right, let's stop this and I'm going to do something. I'm going to say, I'm actually just going to do this all at once. I'm going to say for int n equals 0, n is less than 11,000, n plus plus. I just want to know that I did this correctly. I'm going to just run through the whole algorithm 11,000 times. Then I'm going to render it, and I'm going to say no loop. So it's only going to do it once. Okay? So this is, instead of watching it animate, that looks pretty good, right? That looks exactly like, hopefully, that. Yep. I can verify that these, oh, well, it's flipped. But that's fine, because y is up. Well, you could flip it if you want. I flipped it. Fine. Okay, great. So that is working. We're done. Yay. But this is making me crazy, because I'm only changing one pixel every frame. So I can't bear to leave it this way. I'm going to do one. There's so much refactoring of this that you could do. And actually, I'm going to leave that in here, because one thing, but just having this in here, by the way, and taking out the no loop, like this I can make it appear to run much faster. Like this is doing five cycles per frame of animation. So to make this more clear, what if I did 100 cycles per frame of animation? Whoops. You can see that this is happening much faster now. Whoa. Oh, whoops, we have an error. Array out of bounds exception. Okay, where did I not, what did I not do correctly? If it's greater than width minus 1. Greater than height minus 1. Okay, good thing I checked that. Let's try this again. Yeah, there we go. So we're going to get some pretty crazy patterns after a while. Whoa. And I'm sure you could be clever and think about like modifying the rules to use color. Maybe you could have multiple states. So this is actually running super fast because processing can really handle doing it at this resolution. But you know, we could ask like, what if I do this at like 1200 by 800? Like, ooh. So we also had an error if it's not a square. So I have to fix that. Wait, well, hold on. Let's 120 by 80. Is that the error? Yep. And somewhere I have a mistake in my code. What if I do it 80 by 120? Yeah. So where if oh no, because hold on. Width divided by 2, height divided by 2. Oh no, that's fine. And 120 by 80. That worked. No. So I times width plus j. Oh my goodness, I have this totally wrong. That formula worked. That's why I was on its side. I had this formula wrong the whole time. I referenced my tutorials and everything. I just did it really quickly. That formula was wrong. I need to look at the the column, and then add to it the row times the width. Well, glad I checked. So now this is right. So what I want to show you is what happens if I go to like 1200 by 800, which is probably beyond the, wow. So, you know, processing it really is not having a problem doing this super fast, but I could make this much more efficient. So the way that I'm going to do that is I'm going to make a p image. I'm going to call that ant. And I'm going to say ant equals create image with height RGB. So I want an RGB image. And I want that to be white to start with. So there's probably a way for me to do this more efficiently, but I'm just going to set every pixel of that image to white. So I'm going to set every pixel to white, and I'm going to say ant.load pixels, ant.update pixels, and then I'm going to, instead of doing all of this, I'm just going to draw that image. So that's me drawing the image. Now, the only thing I need to do is change the state here. So what I need to do is I need to do it though before I move forward. But we're always going to move forward, right? So that move forward doesn't actually have to be in there. It can be down here. And I can now find that pixel location as x plus y times ant.width, right? That's the pixel location in that image. And now if I say ant, I might not even need the load pixels, but I'm going to put it in here anyway. Ant.pixels, and you know what? I could just use set. Because I'm just doing one pixel at a time, the set function internally calls load pixels and update pixels for you. So I can just say ant set the x, y to the color. And so I'm going to say if grid x, y equals 0, then the color should be black. So we're going to assume the color is white, and we're going to make a color. We're going to assume the color is white. If it's 0, we're going to set it to black, and then we're going to set that pixel. So this is me just doing that one pixel at a time, because I only change one pixel per frame or per cycle here. I'm actually doing 100 per, and you can see this is the same exact thing. Did it work correctly? Let's go back to, let me just see here. I think I might have a slight issue. Let's double check. Let's double check that this is right by resetting this back to 400 by 400, doing this 11,000 times, and then saying no loop. And let's see here. Is this location correct? Let's see. Now let's take a look at that as compared to the Wikipedia. Again, I'm doing like a mirror image of it, but yeah, that looks right. So I think it's right. So now we could let it run. Again, the same way, let's do, we could probably do like 500 per. The thing is, the fact that I'm doing 500, so really if I want to, I should really be smart about this and say ant load pixels. To be the most optimized, I shouldn't use set. And I should say ant load pixels, ant update pixels at the end of all of this. And then I should say the location is x plus y times ant.width. And I should say ant.pixels. That pixel location is that color. So this would actually be the most optimized. So I'm only calling up load pixel and update pixels once, only changing the pixels that need to be changed. And then I should be able to do this. And what did I miss? Oh, I have no loop in here still. I should be able to do this at very high resolutions really fast. So for example, I can change this now to full screen. And run it. And it should have no problem doing this super fast. So let's let this run for a little while. I'll be back in a minute or two. This will be it. And you'll see me again after this ran for a while. The if condition is backwards. Could be. All right, so hold on. Maybe I'm having some errors. So while this is running, let me look at the code. So what's wrong possibly here? Oh, if it's 0, it should be if it's 1. Oh, I'm back from you waiting because I think I got this wrong. It should be black if it's 1. So hold on a sec. Let's run this again. There we go. And again, this is going to run for a while, and then I'll be back to see what the pattern is. See you in a minute. Okay, I think I got it right. Right now, is it right? Me, I am, so me? We got to wait a while before it actually finds itself. And this is, by the way, not part of the design. Ah, there we go. We're getting something now. What time is it? All right. Oh, there's a number file video? So I should reference that one. Okay. Okay, so this is what it got to. I can sort of zoom in here and see like what sort of interesting, beautiful patterns are here. Someone in the chat told me there's a number file video about Langton's ant, which you can get more of the background, the history of it, and the possibilities. I would encourage you, here's some things you could do. You could refactor my code to make it more efficient. You could think about how would you make this have color in an interesting way. Maybe the grid isn't just pixels. Maybe it's not even just squares. Maybe it's a grid of interesting shapes or patterns. You use color in some way. What kind of beautiful thing can you make from Langton's ant? And if you want to make this run on the web, take a look. I'll also create a JavaScript version of this. But again, I think if you want to get this sort of like full screen speed of it, you're probably going to want to do it in processing. So thanks, everybody, and see you soon. Just in case, I'm going to make an intro in case Mathieu wants to use this. Hello, you're about to see a coding challenge where I produce this, Langton's ant. I'm using processing, which you can get at processing.org. It's a Java-based programming development environment and library, which you can find other videos where I talk about it some more, but I thought I would mention that since I've been using JavaScript in almost everything. But I also will make a JavaScript version that I will post, and I also should mention, if you want to learn more about Langton's ant before you watch me do the code for it, I'll link to a number file video all about it as well in the description. Okay, thanks and enjoy the challenge. Okay, so in case it's useful to use that when it gets edited together, I'll have Mathieu use that. Okay, everybody, I have got to go. I think we did a good job today of getting a little bit through. Yeah, this will make a nice thumbnail too. Oh. Yeah, I'm going to keep letting it run. I'll see if there's any questions. I mean, one thing I should do is I could really increase the speed. Do you guys mind? Because I really have to go. I want to just increase the speed. Oh yeah, you should so you should try all these things. But I just want, for my own sake, to just have it run like, I think I could do 10,000 no problem. Yeah, see how fast this is? Like, let's do, we could do 100,000 pixels no problem each frame. Yeah. So there we go. That's 100,000 pixels each frame. It just looks like noise to me, but is there a pattern in there? Hello, YouTube compression. Whoa. Whoa. Okay, I've got to go, everybody. Thank you for tuning in. I should read a couple random numbers before I go, because maybe some of you are at a place where it's your bedtime, you want to lie down, curl up, get cozy with a blanket, it's cold outside, light the fire. 2,889, 69,618, 72,475, 17,768, 62,088, 49,737, 44,873, 79,110. 3,320, you thought it was done. 21,175. 1,450. 36,512. I really should have this in the background. 65,737. 30,571. 69,318. 85,084. 27,925. 97,538. Thank you everybody for tuning in. Tuning in to this week's Coding Train. I'll be back next Friday. I will continue the neural network stuff. I'll be doing the feed-forward algorithm. If there's time, I'll be doing the back-propagation algorithm and solving one or two simple problems. And then I'll be refactoring using DeepLearn.js, all that stuff. I'll get to it when I get to it. So thanks everybody. And if you're interested in that book, you can go to Amazon.com/shop/thecodingtrain and get your very own copy of 1,000,000 Random Digits with 100,000 Normal Deviates. Unfortunately, it's a reprint. If anybody knows where I can get original copy 1,000,000 Random Digits, like, I would love to get an original copy, not the reprint. Does it exist anywhere? I don't know. So maybe on eBay or something. If anybody finds one, tweet it at me. And my New Year's Eve was excellent. Bye, bye, bye. Good night, England. I'm just looking at the chat for a few last things. This is my goodbye song. I will let that stick around. So I'll look and answer any questions for 2.5 minutes. Arduino programming. I don't do a lot of Arduino programming, but there is, if you go to ITP, the program where I teach has amazing Arduino and physical computing resources. If you go to itp.nyu.edu/physcomp, which is this URL right here, and go under videos. I mean, first of all, there's tons of non-video tutorial information, but since we're here in the world of videos, they're in this album, I think. So these are an incredible resource of videos doing all sorts of physical computing stuff made by Jeff Feddersen and Tom Igoe, and you can see with guests like Benjamin Light. And so I highly recommend you check these out. Maybe I can get some physical computing folks to be a guest sometime. Alka asked, I have an Echo Dot now. Are you still doing Alexa stuff? I would like to do, I didn't get to, was on my list for the fall, doing an Alexa skill, a bunch of tutorials doing it. Right now my priority is those neural network examples, but Alka, I would like to come back to that if I can. Shaders, I would like to get to that as well. Computer vision with OpenCV. There is a wonderful book that just came out. Brian Chung, Amazon. Oh, I should put this, OpenCV. I need to put this on the page, this book. I have a copy of it. Yeah, I have a copy of it. Am I logged in as myself? I'm never going to be able to log in as myself and add it to my... Anyway, I need to add that to the page. Somebody will tweet me and remind me to do that. I need to add Brian Chung's book. It's wonderful, and I keep meaning to write an Amazon review for it. C#. What are my New Year's resolutions are to cook more. I'd like to cook. Oh, living in New York, I ordered a lot of delivery and eat out a lot. I want to cook more. That was my main New Year's resolution. Will I ever turn myself into a cyborg? Well, I do have a large amount of titanium in my arm right now. There's quite obviously a screw right here and a metal plate you can feel right here. So I'm part cyborg, I think, already. processing in Python mode. I would like to look at that as well. I'm not really that much of a Python programmer. How many years when you started programming? I started programming at the quick answer to this is I did do some programming in middle school. I did assembly language in basic and in elementary school. This would have been in the 80s. But then I didn't actually program again at all until I think I was 28 or 29, a whole bunch of years ago. So I learned at this program called ITP where I teach. And so that we have an undergraduate program and a graduate program here. Interactive media arts, interactive telecommunications programs. I usually include links to those in the video descriptions if you're interested as well. Okay, so yes, I should start a whole new YouTube channel. I was thinking of, here's the other thing. Anybody interested in a gaming channel? No, a Nintendo Switch arrived, and I've been kind of getting a little. And I'm not really addicted to it, but I've been playing a lot of Let's Dance. Anybody play? I could practically do everything to another one. I could do the entire dance routine to another one bites the dust. But I will get a copyright violation if I play it here. So I'll have to. Anyway, so someday I've been learning some new moves like it's like this is one of them. If anyone's ever played Let's Dance on the Nintendo. Okay, see you guys. I gotta end the stream now. I'll see you next Friday. Thanks for tuning in. Anybody wants to trade Nintendo Switch games? I'm looking for, or wants to sell me some used ones at a low price. I'm looking for Odyssey. I need to get the ones I want to get ARMS, Zelda, Super Mario Odyssey. Those are on my list. I'll just get them off eBay. I can't bear to pay full price for these games. So I'm going to start looking on eBay. Okay. Where do I hit stop streaming? There it is. Okay. Goodbye, everyone.